My name is Wynn Whiteman, and today we are going to explore the topic of average or mean. Now, if I had to ask you what you understand by average or mean, I'm sure most of you will tell me sum over number. But today we are not looking at the formula. Today we are going to look at the meaning of the word average or mean. Let me explain to you. Last week, Friday, I went down to our school's cafeteria and I was talking to the cafeteria lady, Miss Marcel. She looked a bit perplexed and confused. So I asked her, Miss Marcel, what seems to be the problem? She told me she was in a bit of a bother. She said Monday she prepared 5 lunches, Tuesday she prepared 9, Wednesday 8, and Thursday 6. So she was wondering, Miss Whiteman, how many lunches should I prepare on Friday? She did not want to prepare too little bit, and then some teachers would not get, nor did she want to prepare too many, and then it would be wasted. So I said to her, okay, Miss Marcel, let's see. Let these cubes here represent the lunches that you prepared. So we set out the cubes. Monday had 5, Tuesday had 9, Wednesday 8, and Thursday 6. So I told her, you think we can probably move them around to get equal amounts on each day? So I said, okay, let's move them and shift them about a bit. So I proceeded to do just that. So we moved them about, and then we discovered that each day we could have gotten 7 per day. So I told her, you know what, Miss Marcel? It would be very wise to prepare 7 lunches on Friday. It may be a little too much for the 5, but then again, it may be just a little bit less than the 9. That way, if more teachers want, you can prepare how many extra you need, and if fewer teachers want, then it wouldn't be that many that would be wasted. So what did we do? We actually took all the lunches together and then we separated them into equal amounts. So we got 7 lunches per day. So I told her, I think 7 would be a safe number. Boys and girls, what we did there is in fact average. What we did, we took the sum of all the lunches she prepared Monday, Tuesday, Wednesday, and Thursday, and we shared it equally among all the 4 days. That meant we took 5, 9, 8, and 6. We added them all up, and then we distributed them equally, so each day had 7. Let's look at that again. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2, 4, 6, 7. 2, 4, 6, 7. Okay, so let's put that on the board. Monday, we had 5, Tuesday, 9, Wednesday, 8, and Thursday, 6. So what did we do? We took 1 from the 9, which remained 8, and carried that 1 to the 5. So this Monday now had 6. We took 1 from the 8, remained with 7, and we carried that 1 across to Thursday, 7. Then we took 1 again from Tuesday, remained with 7, and we carried that 1 across to Monday. So what we observe, that each day we had the same number of lunches. We had 7 lunches catered for each day. We can then make the assumption that Friday, Miss Marcel should prepare 7 lunches as well. So what did we do? We distributed our lunches so that each day would have the same number. In fact, we found the average or mean. Let's look at a second question. What is the average of 18, 14, 23, 19, and 16? So let's put the numbers down. 18, 14, 23, 19, and 16. You would recognize that because these numbers are larger, it will be very time-consuming to redistribute the numbers to get them even. Therefore, it will be a faster method to put all together first and then distribute them. So let's put them together. Let's add them to see what our total will be. 19 and 16. 8 and 4 is 12 and 3, 15. 15 and 5, 20. 24 and 6 is 30. 3, 4, 5, 6, 7, 8, 9. So altogether we have 90. We now have to divide that by 1, 2, 3, 4, 5, as we did with Miss Marcel, Monday, Tuesday, Wednesday, Thursday, Friday. So we're going to divide 90 by 5, and that will give us 1 and 4, 18. Therefore, the average of 18, 14, 23, 19, and 16 is 18. Let's go over again. The first thing we did was to find out how many lunches there were all together. Then we divided it amongst how many days the lunches are provided for. So we will have an average of 18 lunches per day. Okay, now let's look at a worded problem involving average. Remember, we are not using any formulas here. Read along with me at home while I read a question. Tara and Sharon did the same 8 tests. Tara got a mean of 87 and Sharon got a mean of 75. How many more marks did Tara get? You can read it again. And we are going to take out the important information. Tara and Sharon did the same 8 tests. So the first piece of information we have is that there were 8 tests. Tara got a mean of 87 and Sharon got a mean of 75. So Tara's mean was 87 and Sharon was 75. The question asks, how many more marks did Tara get? Now, some students, you may just think it's a matter of 87 subtract 75. But the question asks, Tara got a mean of 87. It did not state that Tara's marks were 87. So the first thing we need to find out is how many marks did Tara get and how many did Sharon get. So let's put that on the board. Tara, you're going to put Tara's. These squares will represent Tara's scores. 1, 2, 3, 4, 5, 6, 7, 8. And when we find the average, that will be 87. Sharon, on the other hand, 1, 2, 3, 4, 5, 6, 7, 8. Her average was 75. So we need to find out the total of Tara's scores. Tara scored, her average was 87 in 8 tests. So Tara's total will be 87 times 8, which would be, let's work that out, 87 times 8. 8 sevens are 56, 8 eights are 64, and 5, 69. So her total is 696. That is how many marks Tara scored. Sharon, on the other hand, her mean was 75. So her total would be 75 times 8, Let's see what that works out to be. 75 times 8. 8 5s are 40. 7 8s are 56 and 4 60. So Tara scored 696 marks and Sharon scored 600 marks. Therefore, the difference would be 696 less 600, which will give us 96. So how many more marks did Tara get? My answer, Tara got 96 more marks. Let's go over this again. The first thing we did was identify that they both did the same number of tests, 8 tests. Tara got a mean of 87. That does not tell us her score. That was just her mean of 87. Sharon got a mean of 75. So what we need to find out would have been the total marks both students got. Therefore, to find Tara's score, we had to take the mean and multiply it by the number of tests, which came up to 696. Similarly, we did the same for Sharon, and it came up to 600. Therefore, Tara got 96 more marks than Sharon. Here we have another question. Again, read it along with me at home. The average of 5 numbers is 72. When a 6th number is added, the average changes to 70. What is the 6th number? Let's read it again, ensure we understand what the question is asking. The average of 5 numbers is 72. When a 6th number is added, the average changes to 70. What is the 6th number? Well, what do we realize in this question? 1, we are speaking about 5 numbers whose average is 72. When we add a 6th number, the average decreases. It changes to 70. Our problem is to find that 6th number. So let's write down what we know. So the total will be 72 times 5. Let's work that out. 72 times 5. 5 2s are 10, 5 7s are 35, and 1 36. So the total will be 360. Now, what does the sum say? It says when a 6th number is added. So let's add that 6th number. 3, 4, 5, 6. Our average now becomes 70. So again, we must find the total. So we're going to take that 70 average and multiply it by 6. So we know 70 times 6. 6 times 0 is 0. 6 7s are 42. So that sum is 420. So what does that tell us? When we have 5 numbers, our total is 360. And when we add a 6th number, the total increases to 420. Therefore, that 6th number can be found by subtracting 360 from 420. That will leave us with 60. So therefore, the 6th number that we added is 60. The average of 5 numbers is 72. We used our diagram, represented our 5 numbers. The average was 72. Thereby, we found our total was 360. When a 6th number was added, so let's add our 6th number, the average changed to 70. So we went and we found our total, which is 70 times 6, which came up to 420. So when we had 5 numbers, our total was 360. We added a number and the total jumped to 420. So to find the number we added, we subtracted and we got 60. Let's have a look at another problem. Again, read along with me at home while I read a question for you. After 5 tests, Mark's average is 79. He wants to increase his average to 85 after his next test. If the tests are all scored out of 100, explain whether or not Mark can achieve his goal. Let's again identify the information that was given to us. There were 5 tests. His first average was 79. Mark wants to increase his average to 85 after his next test. If the tests are all scored out of 100, and this is key, explain whether or not Mark can achieve his goal. Let's put that information on the board. 5 tests, again, 1, 2, 3, 4, 5 tests. His average was 79. What is the next step? Of course, we need to find his total. So we are going to multiply 79 by 5. Very good. Multiply 79 by 5. I'm just waiting to see if you can also get that answer. Let's see. 5 9s are 45. 5 7s are 35 and 4 39. Did you get 395? So that is Mark's total. Let's read on. He wants to increase his average to 85 after his next test. So if he did 5, his next test will bring us to 6. So let's go. 1, 2, 3, 4, 5, 6. Again, these squares are the tests, and his average would be 85. What's our next step? We need to find his sum, the total. So we're going to multiply 85 by 6. That's 85 by 6. Again, I'm going to wait on you to do this multiplication. Let's see. 6 5s are 30. 6 8s are 48. 49, 50, 51. So in his 6th test, he has scored 510. The next piece of information given, the tests are all scored out of 100. Explain whether or not Mark can achieve his goal. So after 5 tests, his total was 395. And after 6 tests, his total is 510. Let's now see how many marks he scored on his 6th test. So we are going to subtract 510, subtract 395. That cannot go. 10 take 5 is 5. Carry it across to the tens column. 10 take 9, 110. 4 take 3, 1. So it means that the difference between the score in the 5 tests and the score in the 6th test is 115. Now, if the tests are all scored out of 100, can he achieve his goal? No. Why not? Because he needs a score of 115 and the tests are all scored out of 100. So Let us write our answer. Can he achieve his goal? Mark cannot achieve his goal because he needs to score 115 on his next test. But the tests are all scored out of 100. Let's recap. The first thing we did, we took out the important information that was necessary. There were 5 tests, his average was 79, so we needed to find the total, so we multiplied 79 by 5 to get 395. So after 5 tests, Mark's score was 395. When he added the 6 tests, his score was 85 times 6, which is 510. Because the tests are all scored out of 100, Mark will be unable to achieve his goal because he needs a score of 115. Let's have a look at another problem. Again, read along with me at home while I read it for you. Maya has 285 stickers. Renee has 350 stickers. And Zara has 175 stickers. How many stickers must Renee and Maya give to Zara so that the 3 girls will have the same number of stickers? We're going to read it again to ensure that we understand the question. Maya has 285 stickers. Renee has 350 stickers. And Zara has 175 stickers. How many stickers must Renee and Maya give to Zara so that the 3 girls will have the same number of stickers? Let's devise a plan to work out this average question. Immediately, what will come to mind? We have 3 girls, Maya, Renee, and Zara. So I'm going to make a table. We have Renee and Zara. What other information is given to us? Maya has 285 stickers. So under Maya, I write 285. Renee has 350. Again, under Renee, I write 350. And Zara has 175. The question asks, how many stickers must Renee and Maya give to Zara so that the 3 girls will have the same number of stickers? That will tell us that Zara has less than Maya and Renee. In fact, what we would like to do is to evenly distribute the number of stickers so that each girl will have the same number. So what will be the first thing to do? We must find out how many stickers there are altogether. So let's add 285, 350, and 175. 5 and 5 is 10. 8 and 5 is 13, and 7, 20, and 1, 21. 3 and 2, 5, 1, 6, and 2, 8. So altogether, they have 810 stickers. But they must have the same amount. So our next step is to have an even distribution of the 810 stickers. Since there are 3 girls, we're going to divide 810 by 3. 3 into 3, 1. 3 into 8 is 2. Remainder 2. 3 into 21 is 7. And 3 into 0, 0. It means that each girl must have 270 stickers. But that's not the answer. The question asks, how many stickers must Renee and Maya give to Zara? Maya, who has 285, must end up with 270. Therefore, we must now go and subtract 270 from 285. That will leave us with 15. So 15 of Maya's stickers must go to Zara. We must do the same thing with Rennie. Rennie has 350, but she needs to get to 270. So we are going to subtract 270 from Rennie's amount. Naught take away naught. 5 cannot take the 7, so we must take 1 from the hundreds and carry it across to make it 15 tens. 15 take away 7 is 8, and 2 take away 2 is 0. Therefore, Renee must give Zara 80 stickers. Let's see if Zara will end up with 270. Let's add. 5 and 5 is 10. 7 and 1, 8, and 8, 16, and 1 is 17. 1 and 1 is 2. So, Maya must give Zara 15 of her stickers and Rennie must give Zara 80 of her stickers. In that way, each girl will end up with 270 stickers. So let's recap what we did. So we must first find out how many stickers there are in all. When we added, we got 810. For them to have the same number of stickers, we must then divide 810 by 3, 270. So each girl must end up with 270 stickers. Maya has more than 270, so she must give Zara 15 of hers, so that she will end up with 270. Similarly, Renee, who has 350, must give Zara 80 of hers. We're going to check back our answer to ensure it's correct by adding Zara's amount plus the amount that Maya gave her plus the amount that Renee gave her to see if we end up with the same 270. Good luck. Goodbye.